right, welcome back. Let's continue from where we stopped. Effects of a change in temperature. I want to give you some few tips that will assist you. If you know these tips, you will not have problem on this topic. First of all, what is a major condition that attached to effects of a change in temperature? We have two kinds of reactions, exothermic and what? Endothermic reaction. Now, the forward reaction in an exothermic system is favored by lowering the temperature. So if you lower the temperature in an exothermic reaction, you will what? You favor what? You're going to favor the forward reaction. That is the product. More product will be formed. While the forward reaction of an endothermic system is favored by the what? Raising the temperature. This is the key. If you know this key, you will not have challenge. Low pressure favors forward reaction in endothermic system. While high temperature favors what? Forward reaction in what? In endothermic system. Let's take an example. This is an example of what? Of endothermic reaction, in which a reaction in which heat is given to the environment, is given off to the environment. It's called what? An exo. A reaction in which heat is released to the environment. Now, this is the production of ammonia called the Haber process. Nitrogen plus 3 moles of hydrogen give us what? 2 moles of ammonia. Now, increase in temperature will do what? Will shift equilibrium position to what? To the left. Why? Because it is an exothermic, don't forget. So when you raise the temperature in exothermic, what happens? You favor what? The backward reaction. That is, more H2 and H2 will be produced. Okay, by doing that, there will be what? Decreasing what? In the equilibrium constants. But decrease in temperature will do what? Shift the system position to what? To the right. Equilibrium to what? Constant increases. So this is the first example I'm going to give you. Exothermic reaction, okay, increase in temperature favors what? The left, okay, while what? Decrease in temperature favors what? The right. So more product is informed when you do what? When you decrease temperature, more reactants are formed when you do what? Increase the temperature. All right, let's take another example under endothermic reaction. This is the production of what? Nitrogen 2 oxide from nitrogen and what? And oxygen gas. In this case, the only condition that will favor this reaction based on temperature is what? By increase in temperature. So increased temperature favors what? Favors the forward reaction because it is what? An endothermic system. If you increase temperature here, you're going to have more yield of what? Of nitrogen 2 oxide. But when you decrease temperature, you will favor what? The backward. That is, nitrogen and what? And oxygen gas will form more than NO2. Okay, another change. Effects of change in what? In pressure. Now, these are the keys about pressure. For a change in pressure to affect a chemical system equilibrium, 2 things are involved. The first step is what? One of the reactants or product in the reversible reaction must be gaseous. Now, if this condition is not met, the first one is not met, there is no effects of what? Pressure in that particular what? Reaction. Now, let me take you back to the previous slide. Now, these are the gaseous. So in this process now, there can be what? A change of what? Effects of pressure, because all of them are what? Are gaseous. This G stands for gas. Okay. Number 2, the total number of moles of gaseous molecules on the left side of the equation, is the reactant, must be different from what? Total number of moles of gaseous molecules on the right hand side. So if you have different number of moles of the gaseous substance of both the reactants and the product, there is no effects of pressure on that particular reaction. Let's take an example. Okay, more tips. If a high pressure is applied to an equilibrium system, the reaction which involves a reduction in volume will be favored. That means that high pressure favors low volume of gaseous substance in equation. But if low pressure is imposed on the system, then the reaction which results in an increase in the volume will be favored. This tips is very, very important. So note it. Let's apply it. Example 1. Using this same equation, this is a production of ammonia, known as what? Haber process. Now, the first condition here is certain because we have all of them gaseous. Reactants, they are gaseous. Products, they are gaseous. So we can affect pressure here. Secondly, there are differences in the moles. This is 1 plus 3 equals to 4. So we have 4 moles or 4 volume at the reactant. We have 2 moles or 4 volume at what? At the product. So now, pressure can affect this what? This particular chemical equation. How is the effect? A high pressure will favor the forward reaction. Why? Because we have a reduction of what? Of volume. So 2 here is lower than what? Than 4. So you need to increase the pressure to do what? To have more yield of ammonia. But if you lower the pressure here, what happens? You're going to do what? Favor what? The backward reaction. Okay. So a low pressure will cause the equilibrium position to shift to the left, favoring what? The backward what? Reaction. Let's take another example. Also, we can do what? Affects pressure because both reactants and products are what? Are gaseous. And secondly, we have different number of volumes. We have only 1 mole of nitrogen, nitrogen 4 oxide, and nitrogen 2 oxide, nitrogen 5 oxide, and nitrogen 2 oxide, Na2,4, Na2O4, and 2NO2. Now, what is the effect? We have a low volume here. 1 is here. We have what? A high volume. 2 is there. Okay? So in this case, we need what? A high pressure. We need what? A low pressure. So a low pressure will favor what? The forward, which is what? Formation of 2NO2. So now, it will push the system to favor what? The forward reaction, to produce more of what? Nitrogen 4 oxide. But when you do what? When you apply a high pressure, it will now do what? Come back to the backward reaction and favors what? N2O4. These are the major keys when it comes to what? Effects of a pressure in equilibrium system. Now let's pick the third example and see. We have iron plus water, and we have Ag3O4, okay, and water. Look up. Here we have a mixture of solid, gaseous, solid and gas. So we are not going to consider the iron because what? It is not a gaseous substance. So while you are finding the moles, this 3 is out because it's solid. There is no effect of pressure on solid or liquid. Only for what? For gaseous substance. So we have equal number of moles. So 4 water, this is steam, and the what? 4 moles of what? Hydrogen gas. In this reaction, there is no effects of pressure because we have what? Equal number of volume of what? Of the reactant gaseous substances. So these are the 3 major conditions that determines the shifts or the effects of pressure in an equilibrium system. Okay, let's move to the another effect. Effect of a change in what? In concentration. This one is very simple. When the reactants are added, what are the reactants? These are the reactants. All are the left-hand side are reactants. When you increase what? The concentration of the reactants, what happens? You're going to do what? Favors what? The forward reaction. Or when you remove most of the products, okay, more product will be formed. So when the reactants are added or products are removed, what happens? The equilibrium system or position will shift to the right, favoring what? The forward reaction. But when reactants are removed, which are the reactants, N2 and O2, when any of these are removed or products are added, what happens? The equilibrium position will shift to what? To the left. This is the backward reaction, favoring what? The backward reaction. So each of the effects, there are special conditions you need to do what? Observe. If not, they will have mix-up when the question comes. So these are examples of what? Of equations that favors that we have to apply the effects of what? Concentration. Look at this here. If you add more of N2 or more of O2, you're going to favor what? Production of nitrogen 2 oxide. But if you reduce any of these, okay, you're going to do what? Favors the backward what? Reaction. Effect of a catalyst. Now, what is a catalyst? A catalyst is a substance, okay, that alters the rate of a chemical reaction but remain chemically unchanged at the end of the reaction. It will not change the chemical contents. It can change the color, the texture, but the chemical contents remain what? The same. Now, what are the works of catalysts in equilibrium? Does not, mark the word, does not change the position of equilibrium, but affect the time. It only increases, either it increases the reaction or it lowers the rate. But the talk of changes the position, it will never change. That is the work of a catalyst in equilibrium. It does not do what? Have any effect on equilibrium position, but rather it makes the equilibrium to be attained faster by the what? Increasing the speed at which the reaction is taking place. Okay, let's look at a few questions from JAMB past questions that relate to the topic. If you look at question 27 from 213 JAMB, in the reaction above, the concentration of SO3 can be increased by, good. So this is an example of what? Exothermic reaction. Delta H equals to minus. When it is plus, it shows that they are what? They are endothermic reaction. So always look out for this to know whether they are exothermic or what? Endothermic. When we have this DH stand for what? Delta enthalpy change. That is change in the heat of the reaction. Enthalpy change. When the enthalpy change of reaction is negative, okay, we call that what? Exothermic reaction. But when the enthalpy change is what? Is positive, we call it what? Endothermic reaction. So this is an example of exothermic system. Now, what is the question? In the reaction above, the concentration of S2SO3 can be increased by A, increasing the temperature, addition of catalyst, off, totally off, decreasing the pressure, off. So A and B are out. So contemplate between what? B and C are out. Focus more on what? On A and D. Are you going to increase in exothermic to favor what? The forward reaction? Or are you going to decrease to do what? Favors the backward reaction? So the answer for between A and what? And D. Now the answer here is what is D. Why am I using D? Because the concentration of SO3 is increased by what? Decreasing the temperature, because the reaction is what? Is exothermic. Don't forget what I told you earlier on before now, that decrease in temperature favors what? Forward reaction in exothermic. But increase in temperature favors what? The forward reaction in endothermic. So don't be confused. Let's take example 2. Question 10, 2020. We are given this equation. 2Hi, hydrogen iodide plus hydrogen gas equals to hydrogen gas and iodine. Now, we have enthalpy change of what? Of plus 10. This is an endothermic reaction. Don't forget. Plus, endo, minus, exo. Now, the question is, the concentration of iodine in the equilibrium mixture can be increased by A, raising the pressure, raising the temperature, adding a catalyst, lowering the pressure. So 1, 2, 3 are off because this is an endo. So the best option there is what? Is B. Why? This reaction is an endothermic reaction, which means heat is absorbed for the product to be formed. We know this is true since delta H is what? Is plus 10. Therefore, for more products to be formed, which is S2 and I2, the temperature has to be increased. Then the equation will shift to what? To the right, to favor what? The production of H2 and I2. Next question is from question 24 from 2019. Okay, consider the reaction. This is endothermic. What will be the effects of decrease in temperature? The same thing. Answer is what? B. Rate of backward reaction will be what? Increase. Because it's endothermic. Okay? So effect of decrease in temperature will do what? Will favor what? Favor the where? The backward reaction. Just get the basic keys. You will not have challenge on answering question on equilibrium. Though they are confusing anyway. All right, question 24 from 2021. This is all about equilibrium constants. For the general equation of the nature, xp plus yq, arrow forward and back, mr plus ns. The expression for the equilibrium constant is, don't forget, product over what? Reactants when they are gaseous. When they are gaseous. They must be gaseous substance. But here is not indicated. So use all of them. But if it's stated, for example, if here was solid, and this here is bracket G, here is out. You focus on what? Q. If here was S and here was Q, here is out. But in this case now, there is no differences. So now, what do? Focus on the reactants and what? And the products. Let this change over your superscripts. This change your superscripts. Now look for your option. Think option C best describe it. Question C, this is R superscript M as a mole times A superscript N all over P superscript what? X times Q superscript what? X. So C is the actual answer of writing what? Equilibrium constant. Product all over reactants. Question 31, 2012 JAMB question. Given the equation above, in the reaction above, high pressure will favor the forward reaction because this is question based on what? Effects of pressure. In the reaction above, high pressure will favor the forward reaction because A, high pressure favors gas formation. No. The reaction is in dynamic equilibrium. No. The reaction is exothermic. No. The process occurs with a decrease in what? In volume. Now look at this. We have total volume of 2 in the product. This is my forward reaction. We have total of what? 3. 2 plus 1 at the product. Okay? So high pressure favors what? The one we have a reduction of equilibrium. So the D best describe what? The answer. Next question, 33 to 15. In the above reaction, the forward reaction is favored by, this is under temperature. Okay, increasing the size of it. Okay, this is temperature effect. Increasing the size of the containing vessel, increasing the pressure, adding a catalyst, increasing what? Temperature. This is what? Endothermic reaction. So increased temperature do what? Favors the forward reaction. Okay, those are the ways or some tips that you have to consider while solving problems that correspond or concern equilibrium of a system. Now let's take the last topic for today, which is rate of a chemical reaction. This is another confusion topic for students. Okay, definition. What do we mean by rate of a chemical reaction? It is the number of moles of reactants converted or the products formed per unit time. The number of moles of reactants converted or products formed per unit time. That is, change in concentration of reactant or products all over time. What is the time taken? What was the change in concentration of the products? That's how you define what? Rate of a chemical equation. Now, collision theory. This theory states that there must be collision between reactant particles for what? Chemical reaction to occur. Both reactants, A and B, must collide together before a reaction to what will take place. Now, effective collisions occur only between reactant particles which possess what? A certain minimum amount of energy called activation energy. Now, if the reactant, okay, do not contain this energy, there is no collision in that particular reaction. Now, the activation energy of a chemical reaction is equivalent to the energy barrier that must be overcome before bonds are stretched and sufficiently broken to enable the reaction takes place. Now, every chemical reaction possesses their respective activation energy. Now, if the energy of the reactant is not equal to or more than the energy of the reactant, the energy of the reaction will never take place. Okay, so minimum amount of energy possessed by colliding reactant particles for a chemical reaction to occur is known as activation energy. Every reaction has its own activation energy. I said that before. Reaction occurs if the energy of the colliding reactant particles is equal or more than the activation energy. Now, if the two reactants, if you combine the energy together, is not equal to or more than the actual energy of the reaction, that reaction will never occur. Point number 4. A reaction with a low activation energy will take place spontaneously, like very fast at room temperature, while that of high activation energy only takes place if energy is supplied in form of maybe heat, light, or electrical energy. Now let's take for example, this is an exothermic reaction, which is defined as a chemical reaction in which heat is given off to the surroundings, e.g., formation of calcium hydroxide from calcium oxide and water. Then endothermic is the opposite of exothermic reaction, a reaction in which heat is absorbed into the system from the surroundings. Example is if we decompose potassium trioxochloride 5, potassium trioxochloride 5, you're going to give us potassium chloride and oxygen. So in this case now, energy is retrieved from the environment into the system. But in this case now, energy is given out from the system to the environment. Exothermic and endothermic. This is the profile for each of the reaction. This is about exothermic reaction, from reactants to products. From this point to this point is called activation energy. Okay, then this is energy release from this point to this point. Reactant to the product, whatever is released there is called enthalpy change. Energy released from the system, enthalpy change. Now for the endothermic reaction, energy is is retrieved from environment to the system. So from the reactant to the product. So from this point to this point is called activation energy. Now the change from products and reactants is called enthalpy change, which is energy absorbed. Now from here is we call activation complex. Okay, then this their profile: exothermic reaction and endothermic reaction. Okay, this is one that involves a catalyst. If the reaction cannot take place on its own, we will introduce a catalyst that support the reaction. Now, it is the actual reaction supposed to take place. Now, this is the profile of the catalyst. So, from this point to this point is the energy of the catalyst on on the exothermic reaction. Then, while the actual reaction on its own is the one on the blue line. Okay, but when the catalyst is given in to do to support the reaction, is the one that shows in the red line. Okay, the next one is this is for endothermic reaction. This is a catalyzed pathway. Then this is This is an uncatalyzed pathway. Of course, this is from this point to this point is the energy of the catalysts. All right. While from here to this point is energy of of the entire reaction. Then this is the energy change that is absorbed from the environment. Then here is called activated complex. Then the reactant and the product. time taken and the concentration or potential what energy. So note these diagrams. Most time they give you exams to label. Some they label it for you to do what? Some they ask you to draw. If it's WAEC, ask you to draw. If it is JAMB, they will give you and say, oh, label X, label Y and Z. So you have to note the diagram very well. Differentiate between endothermic and what? And exothermic reaction. Okay, these are the factors that affect chemical reactions. Nature of the reactant, concentration of and pressure, if gaseous, of the reactant, temperature of the reaction mixture, surface area of the reactant, presence of light, presence of catalyst. I will discuss on the measure one. This is what? Concentration, temperature, and surface area. Those are the major three keys that JAMB normally pick their question from. Okay, let's pick the first one. Effect of concentration of a reactant. Now look at this. It's very simple. When you increase the concentration of a reactant, what happens? You are doing what? You are trying to activate the colliding particles to collide faster. So an increase in the concentration of the reactant will do what? Results in a corresponding increase in effective collisions of the reactants, and hence in the reaction rates, while a decrease in concentration of the reactants will have what? Opposite effects. So in any chemical reaction, when once there is an increase in the reactants, what happens? There is a speed in the chemical reaction. The rate of the reaction what? Increases because of what? There are energy for the colliding particles, okay, to collide together. But pressure only affects gaseous substances in a chemical equation. Okay, what are the effects of temperature? Increasing temperature also do what? Increase the rate of a chemical reaction. But if you lower your temperature, what happens? You bring down the level of the colliding particles in the chemical reaction. So increasing the temperature of the system leads to an increase in the reaction rates. This is because when temperature is raised, energy in the form of heat is supplied to what? Reactant particles. As a result, the number of effective collisions increases and the reactions proceed at what? At a faster rate. So when you increase, just like cooking in your normal houses, if you increase the flame of firewood or add more fire to what happens, your food cooked faster. But if you reduce it, what happens? It lowers the cooking. Same thing applies to chemical reaction. If you apply more heat, what happens? Reaction proceed at a faster rate. Okay, surface area in contact. This one is very common among us, even in our normal kitchen. Yeah, well, you want to prepare maybe yam for myself. If I cut yam into big pieces, it will not cook faster. But if I pieces it, what happens? It will cook faster. So same thing happens to a chemical reaction. So greater surface area of a reactant. Okay, the greater the surface area of a reactant, the higher what? The rate of a reaction. That means that zinc, for example, zinc powder. If I grind a zinc is in solid form, is a metal. If I grind it into powder form, it will react faster than when what I just add it in granules or in pieces. So zinc powder burns quickly in oxygen chlorine than what? Zinc granules. Okay, now the surface area of solids can be increased by breaking it into smaller pieces. That is for greater contacts between the reacting particles. Okay, effect of a catalyst. I have defined the catalyst before, but let me do it again. A catalyst is a substance that alters the rate of a chemical reaction but remains chemically unchanged at the end of the reaction. Mind the word chemically. So the nature, the texture, the color of the catalyst don't really matter. Okay, it might change, but the chemical content will remain the same. So a catalyst operates by providing an alternative route for the reaction to occur. We have two sets of catalysts, negative and positive catalysts. What are their works? Now the function of a positive catalyst is to is to lower the activation energy, otherwise called energy barrier of a chemical reaction, thereby causing high collisions between the colliding particles. That means that when the activation energy of a compound or reaction is lowered, or energy barrier, what happens? There is always a faster rate of colliding those particles for reaction to occur. Okay, let's look for a few questions under this topic and see how we can answer them. If we check JAMB question number 18 from year 2020, that was last year, a catalyst speeds up the rate of a chemical reaction by A, taking part in a reaction, increasing the activation energy of the reaction, lowering the activation energy of the reactant, lowering the activation energy of the reaction. Now, this C and D, you have to be careful. They're almost the same thing, but here we have reactant and what? And reaction. So the real answer is what? Is D. Lowering what? The activation energy of the reaction. If you go back to the previous slide, I said that we have two kinds of catalysts. Okay, positive catalysts act by what? Lowering the activation energy, which is what? Energy barrier of a chemical reaction, thereby what? Causing high collisions between the colliding what? Particles. Okay, answer there is what? Is D. In lowering what? The activation energy of the reaction. Okay, 2017 question 10. Which among these factors is responsible for an increase in the rate of a reaction on heating? Which among these factors is responsible for an increase in the rate of a reaction on heating? A, increasing in enthalpy, decrease in activation energy, increasing in collision rates, increase in reactant what? Concentration. The answer is what? Is C. Why is it C? On heating, the kinetic energies of the reactant particles increase, thereby increasing the collision rates to increase, thereby increasing collision rates. So a higher fraction of the reactant particles have necessary minimum energy to react. Hence, reaction rate increases. Next question. 39 from 2015. The preference in the usage of asbestos supports to platinum block as a catalyst can be attributed to it. The answer is what? Increase the surface what? Area. That is the answer. Increase what? The surface area. Question 29, 2014. In a chemical reaction, the change in concentration of a reactant with time is, that one is simple, rate of a reaction. Rate of a reaction. Okay, look at the graph. Look at the graph. This graph shows exothermic reaction. So this is the actual reaction. This is the catalyzed pathway. What is the question? In the graph above, the activation energy of the catalyzed reaction is, don't forget, this is the catalyzed reaction. Have you seen before? This is the actual reaction. So now go to the graph, count the grid very well. From 0 to 200 is catalyzed. Reaction starts from where? From 100. So if you subtract 200 from where? From 100, that will give you what? Your answer. Because they mentioned what? Catalyzed. If it will be uncatalyzed, you start from where? 300. From 300 to what? To 100. Okay, so the answer here is what? Is 100. So from the graph, the activation energy of the catalyzed reaction is what? 200 minus 100. That gives us what? 100 kg. Okay, this is another clear example. You are asked to find either X or Z. Let's see the question. This is the reactant A plus B. This is a reactant A plus B, product C and D. This is our what? Our activation energy. Don't forget, this is what? Enthalpy change. Energy what? Energy absorbed from the environment. This is our activated complex. Okay? If it will be WAEC, now they can ask you to draw and label. But WAEC, JAMB will not ask you to do that. You can only draw for you to label. Now let's check what they ask us to do. Okay, Z. Z in the diagram above represents, go back to the reaction. Where is Z? This is Z. Let's check the options. Activation energy, which is not. Free energy, no. Entropy of reaction, no. What is the answer there? Heat of reaction, otherwise called enthalpy change. So you have to study the diagrams I give you before very well, note their labeling, and so on. All right. So question 33 2017, which of the following would introduce the greatest increase in the rate of the chemical reaction above? Which of the following would introduce? Please mark the keyword, greatest what increase. Now, among all the factors affecting rate of a chemical reaction, which of them are very, very important? There are two: temperature and what? And concentration. The others are just addition. So let's look at the options. Increase in temperature and increase in what? In concentration. That's it. Decrease? No way. Increase in temperature and decrease? No. Decrease in temperature and increase in concentration of the reactants. Okay, decrease. So this one spoils the answer. So it's an increase in temperature and also what? Increase in what? In concentration. Those are the major factors that affect the rate of a chemical reaction. Okay, this is another table. Okay, this is a rate curve of a chemical reaction. But here we have the factor is affecting. Let's look at this. This is powdered marble. This is marble chips. I think this will be a question under surface area. Don't forget, the greater the surface area, the higher or faster the rate of the chemical reaction. Now look at marble chips, higher powdered form, higher what? Greater surface area. Marble chips, below what? Powdered. Okay, let's look at the question. The graph above demonstrates the effect of, back to the graph, powdered marble chips. So this is surface area in contact. This one have what? A higher surface area than what? Marble chips. Let's look at the answer. The graph above demonstrates, just say which of the factors affect that diagram. That is the question. A, surface area on the rate of a reaction. Catalyst on the rate of a reaction. Pressure, no. Concentration, no. The answer is what? Surface area of the rate of the reaction. That is where we draw the curtain for today's class. Thank you very much. Please go through the slide, read it very well, and study the keywords and the key points on each of the slides. It will assist you in answering questions on those topics. Thank you. Have a lovely day.